Hi, I'm Ravindran from AADS department. Today, going to explain our project, which is multimodal machine learning for automated sleep stage classification and sleep duration estimation. Um, we have 12 agendas in our project, and the first is in introduction, which is in our life, sleep plays a vital role in maintaining physical health and cognitive performance of a human being. It is divided into some parts, such as wake, non-REM, N1, N2, N3 stages. In traditional sleep analysis, we use manual scoring, polysomnography signals, which is time-consuming, subjective, and resource-intensive. And also, we have used machine learning to enable automated sleep stage classification. However, it uses single physiological signals, often to capture full complexity of the dynamics. And in the statement of problem, we use accurate sleep stage classification, sleep duration estimation, which is essential for diagnosing and monitoring sleep related disorders. In that, it relies on manual interpretation of polysomnography signals, which is time consuming, and it's also costly. In existing automated approaches, we often use single modality physiological signals to capture sleep dynamics. In that, we need automated, reliable, and scalable multimodal machine learning framework which can accurately classify sleep stages and estimate sleep duration by effectively integrating multiple physiological signals. The purpose of our project is to give 100% classification on our project, and it also reduce dependence on manual scoring by improving efficiency, consistency, and scalability to provide a reliable system which supports clinical decision making and long-term sleep monitoring. The purpose for methodology of our project is data collection, data pre-processing, deep learning, model development, multimodal fusion, sleep duration estimation, evaluation, and validation. In data collection, we get data from EEG, EOG, and EMG, which is publicly available sleep dataset. In the pre-processing stage, we use noise removal, filtering, normalization, segmentation of signals into standard 30-second epochs. In deep learning model development, we use design and train deep learning models to extract special features and classify sleep stages. In multimodal fusion, we use combined features of multiple physiological signals to improve accuracy and robustness. In evaluation and validation, we use F1 accuracy and coherence kappa, which helps to perform a model performance using such matrices. In architecture diagram, we can see data, signals, pre-processing, classification, validation, and sleep stage. In at first, S sketches is 1 and 2 moves into signals where we get EEG, EMG, and EOG. Then it move into data pre-processing, which is segmentation, wavelet decomposition, and touchless free feature extraction. And then it moves into classification and validation, where we get assembled back to tree classifier, 100% of holdout validation, and finally we enter into sleep stage classification of wake, N1, N2, N3, and REM. Then we have a use case diagram, which is uh, where several actors acts on different role. For example, patient upload sleep data, then it moves into pre-process signal. Finally, they get the extract futures, and clinician where it classify, then estimate, and finally get the final details. And researchers moved into sleep data set, and then they go into trial model and finally evaluate the model performance. In class diagram, we can see that object, it's simply template from which objects are created, classes from main building blocks, and object oriented application. This is the overall literature view of our project. I have already explained you the problem statement as well as problem approach. Now, the main advantages of our project is to utilize large-scale multimodal sleep data and also improves generalization across different data sets. And we have also, at the same time, we have also some drawbacks in our project, which is requires a extensive computational resources, high dependency on large, high data quality data sets, integration with wearable and home-based sleep monitoring system extension to real-time sleep analysis. And have used several algorithms which helps to predict accurate classification and improves interpretability in model decisions. And also it highlights the important approach which is within the sleep sequence, and it enhances classification accuracy, and it suppresses less informative time steps. We have also used a certain hardware and software selection. These are the hardware and software which is required to run the particular project. Next, this is the implementation of our project. This is the code, and this is the final output of our project, which is multimodal CNN LSTM long short term memory. This is the functional requirement: data input, user management, signal preprocessing, future extraction, sleep stage classification, sleep duration estimation, result visualization. These are non-functional requirements as well as SDG goals. And finally, we have the conclusion of the project presents automated multimodal machine learning framework for accurate sleep stage classification, and also we are try to give accurate prediction based on the sleep stage classification.